So hello everyone. Our project is titled Student Performance Predictor. This work is done by Ritik Sharkar, Samia Tahiyat, and myself, Mohammad Hassan Saleh. The goal of this research is to predict student performance early in a course so that educators can provide timely support through tutoring, counseling, or adaptive resources. We use machine learning models trained on demographic data, prior grades, attendance, LMS activity, and assessments. Models like linear regression, decision tree, random forest, SVMs, and neural networks are compared. Results show that ensemble methods perform best, and interpretability tools like SHAP and LIME highlight the most important risk factors for educators. Currently, many institutions rely on manual monitoring, which is slow and often too late. Our objective is to build predictive models, evaluate them using metrics like MSE and R-square, and make the result interpretable so educators know who is at risk and why. Previous studies show that combining data such as grades, attendance, and demographics improves accuracy. Decision trees are common and interpretable, but ensemble and hybrid models usually perform better, sometimes reaching over 99% accuracy. However, challenges remain, including inconsistent evaluation methods and limited use of interpretable models. Researchers recommend focusing more on ensemble approaches and explainability, which is where our study contributes. In short, our research builds on existing work to develop accurate and interpretable models for predicting student performance, aiming to support early interventions and improve student retention. Thank you.
Hello, my name is Ritik Sharkar. I will be explaining the pre-processing and the models that we used. For the pre-processing part, we first dropped the irrelevant columns such as reason, guardian math, and guardian poor. Then we checked how many null values are there, and then we filled those null values using the mean for the numerical columns and the mode for the categorical columns. And then one-hot encoded the categorical values so that they are now numerical values. And then we did some feature scaling. And for the models, we used decision tree for multi-output regression and check the score of MSE and R-square score. We also used random forest regressor for multi-output regression since we have 6 outputs, and we checked the MSE and R-square for this as well, and we used linear regression for multi-output regression as well, and finally we used the support vector regression for multi-output regression. And then we use the neural network, the MLP regressor for multi-output regression, and in the end we got our proposed model, which is a manual voting ensemble model, which uses predictions from linear regression, random forest, and SVR, not just their average, their weighted average, taking 20% from linear regression, 60% from random forest, 20% from SVR, since random forest gave the best result. And that's it.
Hello, I'm Samia Tahiyat. Now for result and analysis. Our primary finding is that the voting ensemble model significantly outperformed all other approaches. It consistently achieved the lowest mean squared error and the highest R-squared score, which signifies the most accurate and reliable predictions. The strongest individual model was the random forest, which also demonstrated robust predictive power, though it was slightly surpassed by the ensemble. Then, in contrast, the decision tree model was the most poorly performed model. Its high error rates and negative R-squared values indicates a significant issues with overfitting, which indicates that it is unsuitable for this application. Beyond predictive accuracy, a key objective was to understand the drivers behind this results. This led us to our model analysis. We approached this in 2 layers. First, we identified the most influential factors at a global level across the inter-student population, which was SHAP. Our analysis revealed 3 key determinants. The most significant factor was the number of past failures. This had the strongest negative correlation with final grades. The second was study time, which had a clear positive impact on predicted outcomes. And third, we identified travel time as another relevant factor, where longer commutes were associated with lower grades. Next, we explored the model's reasoning on a local or individual level, which was LIME. We were able to detect specific predictions to understand their composition. For example, the model could attribute a high predicted grade for a student to a specific combination of factors. From all of our findings, we noticed SHAP complemented LIME by offering both direction and magnitude of influence, enabling more fine-grained interpretation. In conclusion, our study had 3 primary takeaways. First, ensemble methods provide a more robust and accurate framework for predicting student performance compared to single models. Second, model interpretability is essential. By leveraging techniques like SHAP and LIME, we transform the predictive model from a black box into a transparent tool that offers clear and actionable insights. Our analysis confirms that students' academic history and current study habits are the strongest predictors of future success. Thank you, everyone.